Hi viewers, hope all of you are doing fine. I am back after a long time. Today I will solve some electronic circuits. So today I will solve some half-wave rectification circuits from Boylestad. So this is example 2.6 from Boylestad book. So let us draw the circuit given in the book. So this is V input and this is the V output, and the diode is given. So let us assume this is ideal diode. The polarity is, this is plus, the minus. So the given input, V input, is a sinusoidal signal. Let us draw the input signal. So the V input, the maximum value is Vm. So the input signal is given and this is the resistance R. So we have to find out the output voltage measured across this resistance. So what is the output voltage wave shape? So for finding out the output voltage, we have to analyze this circuit in two parts. First part, we have to identify what is the characteristics of this circuit for the first half cycle from 0 to T/2, and what is the characteristics of this circuit for the second half cycle, that means from T/2 to T. Now for the first half cycle, that means from 0 to T/2, this is a positive voltage. So this positive voltage will be applied to this diode and it will trigger the diode on. So this is ideal diode. The diode will be a short circuit. So let us draw the equivalent circuit for the first half cycle, that is from 0 to T/2. The equivalent circuit will be like that. So the diode given here is on, so it will be replaced by short circuit. So this is the input signal given. We have to find out this output. So the input signal given is the positive input signal. So let's draw it here. This is the positive input signal. From this circuit, we find that input voltage and the output voltage both are connected at same point. So the output voltage will be exact replica of this input signal. So the output voltage V out, so the output voltage will be exact replica of this input signal. So the same input signal will appear at the output. Same input signal will appear at the output because both are connected at same point. Now for the negative half cycle, say for the from T/2 to T, this is the negative voltage. So the negative voltage will trigger the diode off and the off diode will be replaced by open circuit. Let us draw the equivalent circuit. So the diode given here during the negative half cycle will be off, and since the polarity is right now will look like this, so the diode will be off and it will be replaced by an open circuit. So this open circuit means that all the input signal given will appear across the diode and the output voltage will be 0. So let us draw the wave shape for the negative half cycle. For the negative half cycle, this is V input. For the negative half cycle, the diode is off So all the appeared voltage will be found across the diode, and the output voltage will be 0. So the output voltage will be 0 against this input signal. Now let us draw the complete wave shape for this circuit. This is the input signal. I have just drawn the same input signal given here at this point. So this is B input, and this is Vm, T by 2, and this is T. So this is B output signal. What we have found is that from the equivalent circuit for the first half cycle, the input signal given at this point will appear at the output. The input signal given will appear at the output. So the input and output will be same. This portion will appear at the output. So same. And for the negative half cycle, from this circuit we find that the output voltage will be 0. So for this negative half cycle, since the diode is not conducting, so this is open circuit, the output voltage will be 0. So the output voltage from this point, we find that the output will be 0. So the equivalent circuit for the complete sinusoidal signal is drawn. For the first half cycle, the input signal is found at the output, but for the negative half cycle, the output is 0. So through this rectification circuit, half of the input signal is removed. So this is called a half wave rectification circuit. In the next videos, I will show what will happen if the diode is reversed, or if we add some additional voltages as a clipper or clamper, what will happen, that we will show in next videos. Thank you for watching.